Methanol is an essential ingredient of modern life. It's used to produce thousands of everyday consumer and industrial items, and is also an innovative, clean-burning alternative energy solution. Methanol is a chemical building block used to produce thousands of products that touch our daily lives, including building materials, paints, polyester, plastics, health and pharmaceutical products, and many others. As a clean fuel, methanol significantly reduces engine emissions of sulfur oxides, nitrogen oxides, and particulate matter, which can help improve local air quality. This also makes methanol an attractive alternative fuel for vehicles and ships. It is also used as an energy source for heating homes and cooking, and a hydrogen carrier for fuel cell technology. A clear, colorless, biodegradable liquid, methanol occurs naturally in the environment. On a commercial scale, methanol is most commonly made from natural gas, but it can also be made from renewable sources, such as waste, biomass, and recycled carbon dioxide. The increasing availability of both renewable and low-carbon methanol means that methanol is a future-proof energy resource and an essential part of the solution in humanity's push for a sustainable future. Methanol has been used for over 100 years, and every year, billions of liters of methanol are safely produced, shipped, and distributed around the world. As methanol is used in more and more applications, it is critically important that those who work with and handle methanol understand its physical properties and important safety features. For the Methanol Institute, the trade association for the global methanol industry, product stewardship is priority number one. Our product stewardship efforts seek to protect the safety of people and the environment throughout the product life cycle, from production, storage, distribution, use, and disposal. So what is methanol, and what are its physical properties? Methanol is the simplest alcohol molecule and is a clear, colorless liquid at room ambient temperature and pressure. Methanol is rich in hydrogen, biodegradable, and clean burning. Like other chemicals and fuels, methanol must be used and handled safely. There are two key safety risks which are important to understand and manage to keep people and the environment safe. Health risks. Firstly, methanol can be toxic if swallowed, inhaled, or absorbed into the skin. Appropriate care must be taken to avoid ingesting, having skin come in contact with, or breathing in methanol vapors. Secondly, methanol is a flammable liquid that burns with a clear blue flame, which makes it difficult to see in bright light. Although methanol occurs naturally in the human body as a result of our diet, higher concentrations of methanol are toxic to humans. For those who work with and handle methanol, it's important to understand the risks of methanol and prevent exposure through the 4 ways methanol can enter the body, including inhalation by breathing in methanol vapors, absorption in the skin, eye contact, and ingestion. When working around methanol, protect the 4 routes of entry into the body by always wearing the appropriate personal protective equipment relevant to the level of exposure risk. When working around methanol where there is a low risk of exposure to methanol vapors and low-volume methanol splashes, ensure to wear fire-retardant clothing, nitrile gloves, safety glasses, and boots. When working around methanol where there is a high risk of exposure to methanol vapors and high-volume splashes, ensure to wear full chemical suit, gloves, compressed breathing air, self-contained breathing apparatus, and boots. In addition to personal protective equipment, there are a number of ways to monitor for methanol vapors and prevent potential methanol exposure in the work environment. Methanol has a faintly sweet alcohol odor, but it does not make its presence known until well beyond safe exposure limits for humans. As human odor detection is subjective for each individual and a poor indicator of methanol concentration, it is essential that a quantitative measure of exposure be used to ensure the health and safety of workers and compliance with applicable regulations. Methanol vapor concentrations can be measured using direct reading gas detection tubes, such as colorimetric detection tubes, or with electronic instruments, such as portable gas monitors. Methanol is heavier than air, so if released can collect in low-lying areas. Gas monitors can provide continuous readings of methanol concentrations, and alarms can also be set at specified concentrations. In the event of methanol exposure through ingestion, inhalation, or on the skin, it's important to seek medical attention quickly. Symptoms of methanol poisoning can range from headache, dizziness, weakness, nausea, vomiting, unconsciousness, and visual impacts including blurred vision and blindness. If you or someone else has inhaled methanol vapors, remove the person to fresh air if it is safe to do so, and seek immediate medical attention. If you have been exposed to methanol on the skin, remove affected clothing, wash the area with soap and large amounts of water for 15 minutes, and seek medical attention. With eye contact, immediately flush the eyes with gently running water for at least 15 minutes, and seek medical attention. Ingestion of as little as 10 milliliters can cause blindness, and 30 milliliters can be fatal without proper medical treatment. It is critical to seek immediate medical attention from methanol ingestion and do not induce vomiting. Intravenous administration of ethanol can help block methanol metabolism in the body, and injections of fomepizole can be administered by a trained medical professional. Onset of symptoms may be delayed for up to 24 hours. There are a number of treatment options available for methanol exposure, and outcomes are good when treated promptly. It is critical when working with and handling methanol to understand the risks and take the necessary precautions to protect oneself from potential exposure. The second key safety feature of methanol is that it is flammable. Like all flammable liquids, appropriate safety precautions must be taken to ensure its safe use. Methanol is a liquid at normal conditions, but releases a vapor depending on its temperature. Flash point describes the lowest temperature at which vapors of a liquid will ignite. As methanol has a flash point of 11 degrees Celsius or 52 degrees Fahrenheit, it is classified as highly flammable. Compared with gasoline, methanol burns cooler with just 1/8 the heat. However, a unique feature of pure methanol is that it burns with a clear blue flame, which makes it difficult to see in bright light or sunlight. If pure methanol is on fire, you may not be able to tell, with the only indication being a shimmery heat haze or something burning nearby. Thermal imaging cameras can detect methanol flames, which may not be visible to the naked eye. Appropriate fire safety precautions, such as removing ignition sources, must be taken when working around and using methanol. Do not use cell phones, laptops, power tools, electronic devices, or anything that could produce a spark in an environment that could contain methanol or methanol vapors. Smoking must be restricted to a designated location that is free of potential methanol vapor. Vehicle access must be strictly controlled and enforced. Use of non-sparking tools is highly recommended. The use of intrinsically safe radios, telephones, portable instrumentation, or if the equipment is not intrinsically safe, such as computers, calculators, and other electronic equipment, should only be used with an appropriate safe work permit and precautions and approvals in place. As a rule of thumb, a no ignition source perimeter should be designated, and the adequacy of hazard zone perimeters should be verified. If conducting hot work, including cutting, welding, and grinding, an effective hot work program that includes prior work authorization, safe welding practices, and a fire watch is essential when working around flammable materials. It is preferred that hot work be conducted in an approved maintenance workshop out of the hazardous area. However, if it cannot be done outside the hazardous area, then appropriate hazards must be identified and precautions taken before hot work commences. In addition, to avoid creating static sparks when handling methanol, ensure appropriate bonding and grounding procedures are followed at all times to reduce the fire risk. Should a methanol spill occur, diluting the methanol spill can help to prevent a fire. Water must be mixed and at least 4 parts water to 1 part methanol. Methanol can reignite in methanol water mixtures with as low as 25% methanol. Should a methanol fire of any size occur, call your fire department immediately. Do not try to extinguish a methanol fire yourself without proper training. As part of emergency response pre-planning, it is recommended to invite local emergency responders to your facility in advance of an incident to familiarize them with the layout, storage system, and potential hazards unique to your location. Should a methanol fire occur, the most effective means of extinguishing it is the application of alcohol-resistant film-forming foam. Fixed and portable fire extinguishing systems may be needed. These may consist of one or more of the following: CO2 extinguisher, dry chemical extinguishers, water-based, or foam, alcohol-resistant film-forming foam. In the event of a large methanol spill, call your fire department immediately. Take steps to eliminate all ignition sources, including vehicles. Create a 100-meter or 330-foot isolation area in all directions. If containment is compromised, responders should consider evacuation in all directions for 800 meters or 2,600 feet. Restrict access to spill area and move people upwind of the spill. Personnel entering the area should be in full chemical suits, and firefighters in full bunker gear. Upon leaving the spill area, all personnel and equipment must be decontaminated. For smaller spills, use of absorbent granules, including cat litter, can be used as an absorbent. To recap, there are 2 key safety features of methanol to understand and manage. Methanol is toxic to humans and is a flammable liquid. Appropriate safety measures must be used when interacting with methanol. Every year, billions of liters of methanol are safely produced, shipped, and distributed around the world. Like other chemicals and fuels, it is important to use and handle methanol safely so we can enjoy the benefits methanol provides as a clean burning energy resource and a chemical building block for thousands of products that touch our daily lives. The Methanol Institute is committed to safe handling education for those who may come into contact with methanol to help prevent future incidents and keep people and the environment safe. This safe handling video has provided an overview of methanol safety. For more detailed information, please reference the Methanol Institute's Methanol Safe Handling Manual, which is freely available, along with many other safe handling resources on our website at www.methanol.org.